So we're going to talk a little bit about probability. And here are some reasons why probability has been studied. First of all, we're looking at games of chance like playing cards or throwing dice or lotteries. Another reason to study probability is to look at social science data such as life, death. And when we're looking at scientific data, we want to look for variations in random measurement. In other words, how often would a plant get this big, and does this fertilizer work, for example? So let's take a little bit more look at probability. So here's the big idea. The big idea is, well, you can read this, but the chance behavior is unpredictable in the short run, but has a long and regular predictable pattern in the long run. So it's unpredictable in the short run. So I have an example here. You do not know what the next flip of a coin is, but you know that in the long run, about half the flips are heads, and about the other half are tails. So if you flip a coin 100 times, you'd expect it to be about somewhere in the neighborhood of 50-50. You would not expect to have 90 tails if the coin were fair, for example. That's what probability is. Now, you have to remember something. Probability is a long-run game, meaning short-term probability is a little dicey, so to speak. You don't really know what's going to happen. So it's kind of like a limit. At any interval, it may be hard to see what's happening, but over the long term, we can see a trend. So probability really is about trends, about the long run, and it's never about the short term. Like I said, you can flip a coin 4 times and get 4 heads. That doesn't mean the probability of getting heads on a coin is 100%. It just means it happened those 4 times. But if we're looking at thousands or millions of occurrences, then we expect it to be about 50-50 over the long run. Okay, so let's talk a little bit more about probability. So we call phenomena random if individual outcomes are uncertain, but nonetheless there's a regular distribution of outcomes in a large number of repetitions. And really the important thing here, again, and I mentioned it several times, but the important thing to get out of this is where you see it says large number of repetitions. Let me fix that a little bit. Large number of repetitions. That didn't help much, but it's a long-term game. Large number of repetitions over the long haul. Nothing about the short. So phenomena is random if we can figure out what's going to happen over the long term. And here is probability. It says the probability of any outcome of a random phenomena is a proportion of times the outcome would occur in a very long series of repetitions. That is, probability is long-term frequency. And it says here that computer simulations can allow us to see those long-term frequencies. And especially these days, a lot of times, instead of necessarily relying so much on the math, we can, and the math could be very complicated or nearly impossible, we could run a simulation, have the computer simulate what would happen, say, 10 times or 100 times or 1,000 times. And as it goes thousands and hundreds of thousands and millions of times, we can kind of start to get a feel for what should happen. And the computer doesn't get bored of running the simulations, unlike you and I, so that's pretty good. So we're almost done here defining the introduction to probability. Independence. In order for an event to be considered random, it must be independent. That is, it must not be influenced by other events. So let's talk about something like rolling a dice. If you roll a dice once and you get a 5, and this is a fair 6-sided dice, when you pick up the dice does not know what you rolled last time. So when you roll it again, the probability of you getting a 5 is still 1 out of 6. It doesn't change probability at all. Now drawing cards. If you're looking at a card and you draw a card, cards could influence each other. So I think I have another slide here that'll examine this a little more closely. I do. And in fact, I used drawing cards last time too. So it says flipping ahead does not make it more probable that the tail will occur next, as you should know that. And that's of course for a fair coin. We're assuming you're not trying to cheat anybody. And then drawing cards, the first card does influence the outcome of the next card. If you're looking for a heart and you draw a heart on the first card, then it changes your probability of drawing a heart on the next card, unless of course you put that card back. So the top event is independent. Or, wow, I guess it's not going to work. Anyway, it's independent. There we go. And the bottom one is dependent, because it depends on what occurred before it. So because the top is independent, we can look at the probability for it. The bottom becomes a little bit more complicated. In fact, it becomes significantly more complicated. Maybe we'll discuss that later on. Okay, this is my introduction to probability. So hopefully you took notes and have stopped the video. If not, rewatch it, and we can discuss it more in class.